Welcome to the project demonstration of electrical vehicle BMS with charge monitoring and fire protection using DS18B20 temperature sensor. So in this version we are using main PIC microcontroller which is advanced than the Arduino Uno board, as Arduino Uno consists of 16 MHz of oscillator. Now the PIC microcontroller consists of 20 MHz of crystal oscillator. So there is the speed of our controller. And next another change is we are using DS18B20 instead of LM35, as it is a waterproof temperature sensor along with the probe, so that it's continuously monitoring with high precision temperature of this battery pack. So the coming to the main application of this project is we are going to continuously measure the voltage, current and temperature of this battery pack. Why? Because whenever we are using batteries in electrical vehicles, due to the high voltage or high current or like any short circuit occurred inside that, the temperature will be increases. So we need to monitor these three parameters continuously in order to protect the electrical vehicle from fire accidents, as well as we need to maintain the battery life to get these parameters continuously monitoring by the microcontroller. So that is called battery management system. So here we are using PIC microcontroller to continuously monitor all these three parameters continuously and monitor them on LCD display. And whenever the battery voltage is low, then the threshold value, with help of this fast charging and slow charging, we can control the charge current to this battery pack. So these are the main features. And also whenever the battery temperature is crosses threshold value, then the system will on this cooling fan before getting into the fire accidents. This overheating may occur due to the high charging or high load or any short circuit occur inside this battery pack. So these are the safety system we are providing to the electrical vehicle batteries. So here they are the main features. And coming to the power flow, so we are providing 230 volts AC input to this transformer which is stepped down the 230 volts AC to 12 volts of AC. The output of this transformer is input to this regulated power supply board, which will take 12 volts AC input and provide us the two outputs. One is a 12 volts DC. After this rectification and filtration, rectifier will rectify the AC to pulsating DC, filter will remove the pulses and provide us the pure DC of 12 volts. That is input to this battery pack through this relays. So this is the output. Here we can see this cables, green and yellow wire is connected to this battery pack through this relays. And next, the operating voltage of our electronic components like microcontroller, LCD and relays is a 5 volt. So for that purpose, we are going to use the 7805 regulator. This black color is a 7805 voltage regulator, this one. So which will take 12 volts DC input and provide us the 5 volts DC output. So when we provide that 5 volts DC output to this microcontroller, the PIC motherboard, we are using PIC 16F73 microcontroller, which will take input from the voltage sensor. This is a voltage here is a voltage sensor, and this one is the current sensor and temperature sensor. So these three are interfaced to this PIC microcontroller at A0, A1 and A4 pins respectively. Based on these sensors inputs, the system will provide us the output to the LCD display that was connected pin number B2 to B7, and these two relays based on these two switch input, so which are connected C0 and C1, and relays connected the pin number C6 and C7. And also the audible alert will be provided from this buzzer whenever the low voltage or high temperature occurred, which was interfaced at pin number C4, and C3 connected to this cooling fan through this transistor board. So this transistor board is used to on and off this fan whenever the high temperature is occurred. So they are the main input output connections, and we are using this DC motor which is acting as an electrical vehicle to measure the current, and that will be displayed on the 16:2 LCD screen. So this is about the flow along with the interface connections. Let us see the demonstration. Let us on the power supply to the kit. So initially we can see the welcome message on the LCD screen. So just reset this. There is a reset switch to restart the microcontroller, and this one is a crystal oscillator as we discussed initially. So press and release, it will only restart the microcontroller, it won't erase the program. So there we can see the voltage, I is current. As of now the motor is off state, so that's why I is 0, temperature is 32.4 degrees centigrade. So these are the parameters we are getting now. So let us check. Using this switch we can isolate the power supply to the voltage sensor. Why? Because to make the low battery voltage alert. Now just I am switching off that. Then the voltage will be disconnected to the voltage sensor. So we are getting the 0 volts. The low battery voltage is 8 volts. So whenever the battery voltage is less than 8 volts, then the system will on this buzzer. Using these switches, we can keep this in charging. So one relay got switched on. We can see the another relay got switched on. This is fast charging mode. So now the battery pack is charging in fast charging mode to provide the double the current. And whenever the battery voltage is coming to the normal, okay, the switch is just to make low voltage fault, right? So if you want to make it a real time low voltage fault, yes, you can disconnect this. See, I'm right. Okay, so I'm just disconnect this battery pack by just pressing that. So it will be disconnected from the battery pack and low battery voltage will be displayed on the LCD. So this is about the low voltage fault. Coming to the current. So just on this switch, and the motor is running straight, and we can see the current is 1000 milliamps. So as of now we are using the 1 amp of load. So that's why we are showing the 1000 milliamps. So when it is off again, it is going to be the 0 milliamps. Means there is no load. Okay, and now coming to the temperature. So just using the external heating object, I am going to heat up this temperature sensor. Slowly the temperature will be increased. You can see that. So when the temperature crosses 50 degrees centigrade, then we will get the audible alert. Right. Okay. And also fan got switched on. We can see that the fan is running now. And when the temperature is coming to the normal, which is below 50 degrees centigrade, then automatically the fan will be off. Right, you can see that buzzer will be off and fan also will be off as the temperature is normal. So in this manner, we are going to do the battery management system by monitoring the voltage, current and temperature of this battery pack. So coming to the batteries, we are going to use here a 3.7 volts 2000 mAh battery pack, and that consists of 3.7 volts are connected in series. So we'll get 11.1 volt maximum, and the open circuit voltage maximum is 12.5. So once the battery is fully charged, we can get up to the 12.5 volts. Thank you.